I remember I think I just lay.
You laid down.
I did. I was overwhelmed with.
I get it.
Not many geologists maybe don't think like that. I don't know what geologists think.
No, there's a picture of me in the Flinders Ranges. It wasn't because it was old, but I really like ripples. I love sedimentary rocks with ripples on them, and I like lying in the creek bed and just really feeling one with the story that the Earth is. It's a weird habit, Anthony.
I don't think we should feel ashamed of being.
I don't know. Welcome to Wonder, brought to you by Geo Co. This is a show all about connecting people to planet. I'm joined by my colleague today, Dr. Anthony Reid. I'm Holly Cooke. And today, Anthony and I go into this marvellous concept of deep time. What does it mean to understand Earth's ancient natural history? What does it mean that time leaves a record? And I think we might be able to answer, we're going to try to answer once and for all, can the geologist travel in time?
So, Holly, can you tell me a story about a time when you really connected in some way with like something to do with human history? You know, when was there a time when human history and the depth of time laid itself bare to you?
Okay, tremendous. Only about 24 hours ago, I reckon, I touched back down in Adelaide from the Northern Territory at 6 a.m. this morning and truly had the most tremendous connection. I think the best I've probably ever felt in my life to what it means to connect to ancient human history. And it was in Kakadu National Park. And I believe it was at a place called Burrungkuy and Bung. So a site of pretty ancient rock art. And so we walk in there and it feels very spiritual.
Definitely.
Feels very spiritual. And what you come to realise is that this is a place where there's evidence of habitation for the past 22,000 years. And you go, wow, that's phenomenal. I almost can't think back that long to humans. I can't think about humans going back that far. And then you see this rock art and some of it's dated to only 100 years ago. Yeah. And so you've got this layering of what it means to be human a long time ago with a very profound connection to the landscape around you. And your survival, your well-being depends on your connection to this landscape. And then you can really feel that.
You really feel it in Kakadu. It's one of those very unique places. It's really special. Very special.
And so I'm peering at this rock art and you could just get lost forever there, staring into that. And then you sort of peel back the hematite ochres. You start peeling back that sort of charcoal ochres and you look at the rock that it's sitting on. And blimey, that's a geologist's dream too, because it's a very remarkable sedimentary rock that it's sitting on. And I just thought that 22,000 years was old. But then I'm looking back at something that's, I think, probably over 1 billion years old at this rock here. And so I just had this very profound moment where I was really lost in how wonderful it was to be connected to this ancient human civilization. And then to peel that away and know that I'm equally as connected to the landscape of the Earth 1 billion years ago. It was a very cool experience and one that I've got a bit of even airplane hangover. Yeah, a buzz and an airplane hangover still.
The Kakadu buzz.
Exactly.
Kakadu National Park is a phenomenal place, and hats off to the people who've kept that country wonderful over the generations. And it is very special to go to those rock art shelters and see.
You've been recently too.
Yeah, there's another place that's really important, Ubir Rock, which is this famous place as well where there's lots more rock art. And really interesting there, you see in some of the rock art, you see an image which is a Tasmanian tiger painted on one of the shelters. Now, of course,
they're extinct now.
They're extinct on the mainland, or they're extinct on Tasmania as well, only very recently. But they probably went extinct about 4,000 or 5,000 years ago from memory, in terms of what I've read. So, that really dates some of that material, some of those paintings, we know that those people were living amongst Tasmanian tigers, or what we call Tasmanian tigers, and they painted on the walls, and for sure stories were passed down about those animals, but they disappeared 5,000 years ago or something. So yeah, incredible connection through to ancient culture. Well, obviously in that part of the world, the culture is continuing and has continued. So that's what's amazing.
And especially
about it as well.
in Kakadu continues to this day. Still, the land is still managed beautifully. But so I just went from call it 100-year-old rock paintings to 22,000-year-old habitation to 1 billion-year-old rocks. 1 billion years is pretty cool. Can you top my 1 billion-year-old rock
I'll see your 1 billion and raise you another.
Can you raise me?
Yeah. Oh, 1 billion, come on.
Oh.
No, I'm just joking. So, yes, so I can, yep. I've been incredibly fortunate as a geologist to see some ancient rocks. In South Australia, there are some ancient rocks. So if you go down to Southern Eyre Peninsula and parts of central South Australia, you can see rocks which are about 2.5 billion years old, so pretty ancient. I remember one of my professors, when we went on field trips out to these ancient rocks, describing to us students how he felt a little bit giddy.
Oh,
do you know what I'm like? This sort of excitement that I'm about to see some really, really ancient rock. I'm a really, and just to look at this stuff and go, and think how deep and ancient this material is you're looking at. I think as a student, I didn't really.
Yeah, you went, this is supposed to come on. Pathetic.
When's the is this going to be an exam kind of thing? But I had a similar experience. So, we went up to the Pilbara and in a place near Marble Bar.
Mm-hmm. Hottest place in Australia.
Apparently the hottest place in Australia. Yeah. It wasn't that hot. There were days we were there, but it's obviously a very hot place. Anyway,
38, not that hot. Grow up.
Anyway, they have, I think there are rocks around there at about 2.9 billion. So
that's ridiculous.
A lot of things in Western Australia top South Australia in terms of how ancient the rocks are. Anyway, but I remember getting to that particular right near the Marble Bar. There's a kind of a creek bed. There's a little hill, and there's this sort of bar, a rocky bar, which kind of forms a little natural dam. But those rocky outcrops there are about 2.9 billion years. And some of them are igneous rocks, volcanic rocks, and you can still see the little volcanic textures like little pillows, like how they form underwater. So you can
actually decode them. Not only do you know they're old, but you can actually understand what they're telling you.
Absolutely. They look like something that you can see forming, I guess, near Hawaii now, where the lava spills out underwater and, it sort of forms these little balls of pillows of material as the lava extrudes out underwater. And we can see that same texture in these 2.9 billion year old rocks. But I remember that day, I think I just lay.
You laid down.
I did. I was overwhelmed with.
I get it.
Not many geologists maybe don't think like that. I don't know what geologists think.
No, there's a picture of me in the Flinders Ranges. It wasn't because it was old, but I really like ripples. I love sedimentary rocks with ripples on them, and I like lying in the creek bed and just really feeling one with the story that the earth is. It's a weird habit, Anthony.
I don't think we should feel ashamed of being.
I don't know.
But it's our expression of that. We are, of course, we're rational, we're intellectuals. We kind of think about things in terms of the X and Y axis, but we have
feelings too. The scientists have feelings too.
Amazingly, we have found a population of scientists. We all have feelings, okay? And I don't think you should be ashamed about that. I'm sure marine biologists, when they see amazing octopus or sort of some sharks or whatever they're studying, they would also feel. Maybe you don't know. Go and cuddle the shark, but I felt like that was an appropriate response at that time to just the enormity of what I was experiencing. There were no real words. I mean, the people. My family, whether we were with. I tried to.
Your kids went, Dad, get up.
Come on, Dad.
Yeah.
But
I love that because
there's a connection you have, right?
For sure. Because what's it for? Like, I'm not really interested in playing an analytical game where you produce numbers for the sake of numbers. Who actually cares? This is about something so much more. It's about placing yourself in time in an Earth story. But so you just said 2.9 billion years old. Is it even? How do you actually collect data that you can rely on to what? Like, how do you, 2.9 billion years? It sounds like you could pull that out of thin air. It kind of does. So how do you understand that age? How do you get that age? Because that's stupendous.
Yeah, it's a long time.
What part of nature encodes that?
Wow.
You're thinking, how deep do I go?
Well, how deep do you go? I mean, okay, so, it's like, family history, and people will say, well, this person is descended from this person and these people married and this was the daughter of this person and da-da-da, and you can track it back. And so there are records in some books or whatever where you can actually see, this person signed their name and, so there was a history there. So you can say that was definitely that old. And likewise, you can see buildings or, maybe from the Middle Ages or I don't know, sometime. And And you can say, well, that building we know was built in the 1400s or whatever because it's got a little sign on it.
Yeah.
And so it's no different in terms of, when you go deeper in time. Of course, you lose that written record naturally. 2.9 billion years ago, there was
some of it is self-destructs among natural processes over 3 billion years.
Absolutely, of course, some of it gets eroded and recycled. But yeah, so what it comes down to is that scientists have worked out that some atoms naturally break down. The amount of neutrons and protons in the nucleus of the atom is unstable and it breaks down naturally. It just decays. So this is the principle of radioactive decay, and it's the whole idea is that we can. So you basically you break down that unstable atom breaks down into two new elements, right?
Yeah.
So you start with, say, the one I'm going to use is uranium. So naturally, uranium breaks down. It doesn't. It is radioactive, and what happens is it splits apart, and you form two different new elements. So eventually,
that is cool.
They break down. So they will break down two different elements, and eventually end up with lead. Is one of the final breakdown products that becomes stable finally.
Doesn't want to break down anymore.
No, I mean there are. Yeah, that's right. It doesn't go any further. And so what geologists worked out. So the physicists were onto this first, and Ernest Rutherford and all those, in the early 1900s, and Marie Curie and the physicists who are working out the principles behind radiation. And somebody worked out, so if we could measure the amount of lead that's in something and the amount of uranium that's in something, and because we know that this decays at more or less a constant rate, we could work out how long that lead how long it's taken for that lead to accumulate from the breakdown of uranium.
You backtrack it.
Exactly. So there are all these, equations for working out if you have this much lead, how much uranium, and you have this much uranium which is yet to undergo decay, and you have this much lead, do the equations and you can back calculate an age of how long it's taken to accumulate. So this is the principle of half-life and this type of thing that you've probably heard of.
Oh, cool. So it's almost like trapped in those equations and in those elements is actually sort of a record of time.
Absolutely a record of time, yeah.
Great.
Yeah.
The mineral that I hear sort of swirled around a lot for age keeping is zircon.
Zircon, yeah. So, definitely is one of the key minerals. But there are lots of other minerals. I mean, there's so many different minerals in the world.
Actually, I was reading a really cool paper on this. It's like over 6,000.
There's 6,000 named minerals.
It's fantastic if you think about it's something that flies under the radar a little bit, which is the mineral diversity of this planet. Over 6,000 ways that elements have come together to create different materials with different properties, that create different gems. Like if you're into this, it creates different gemstones and different rock types.
Definitely. 6,000. That's a humongous number.
Huge. Wow. And what's cool about that is some of them are pretty specific to Earth. Like, for example, biology, our living Earth can create minerals, and that's something that so far we only think exists on Earth. So there, Earth is home to to minerals that shouldn't exist elsewhere because we don't know if life exists elsewhere.
Absolutely. Yeah.
We digress. We very much digress.
I'm still impressed with 6,000. That's a good number. Yeah.
Oh, goodness.
Can you list them, or did you read memorize those?
Oh, I didn't make it past the abstract, I got to tell you. No, it's a cool paper.
Who reads the figures in the discussion?
Oh, boring. If it doesn't make me emotional, I don't want it. I don't want it. Oh, cool. So we know that your rock is 2.9 billion years old because of the way that some elements break down when they're contained in those rocks.
Yeah. So it's just a natural process. So those unstable elements, and there's a whole lot of them. Potassium also undergoes radioactive decay.
Bananas.
People always talk about bananas. I mean, don't.
If you're listening, Anthony just did the most ferocious forehead shake.
I mean, bananas, yes, it has potassium, isn't it? But heaps of things have potassium in it. It's not just bananas. So you eat as many bananas as you want. I did read a statistic. I can't remember what it was, of the number of bananas you need to eat to get radiation poisoning. It was a very significant number, way beyond your capacity. You
got more issues than just the radiation if you're eating 200 bananas.
Bigger issues than that. Anyway, so bananas have have a radioactive, like a minuscule proportion.
Don't even sweat it, guys.
Anyway,
pretend you didn't hear that. Yeah.
Potassium and thorium is another one. Uranium is. They're the main three, actually. Though they're the big sort of volume. Yeah, is those three. But there's plenty of others that go.
And it would be right in saying, are those the elements that keep the Earth hot?
Wow, yeah, that's true. Yeah, heat, radioactivity produces heat as well. So yeah, definitely. Yeah, there's a whole story about that, about the Earth's heat and radiation.
That's for a later episode.
For later.
That's for later listening.
For later listening. But yeah, that whole idea of that, if you can measure the what's called the parent isotope and what's called the daughter isotope, you can measure the ratio of those two things, use an equation. But another thing that's fascinating about this whole science of dating minerals and rocks is the equipment that you get to use to do these things. So if you look at, the stereotypical picture of a geologist is us wandering around the bush with, a high vis or a fly net or
a really bland beige hiking top.
But some geologists are also enclosed in lab spaces.
Oh, if you don't want to wear hiking gear, you can wear a lab coat.
Yeah, there's the diversity of geological applications. And one of them is in the laboratories, right? And there's a lot of people who specialise in isotopic measurements for lots of purposes. And they use amazing laboratory equipment for, the volume of material that these instruments are now able to measure is stupendously small. And, just being able to measure kind of nanograms worth of isotope, it's amazing what these instruments can do. Anyway, so you have this kind of great experience of being able to go and collect rocks in the field, and then you can go through that whole process of separating out the mineral that you're interested in. In this case, you mentioned zircon, which is a zirconia silicate, and then you can actually fire laser beams or negatively charged beams of ions. It gets pretty intense, but you can fire these high energy beams into the particular part of zircon that you're interested in, and just get when you fire these high energy material beams into these minerals, a little bit of the mineral gets more or less evaporated. Yeah. Right, and it gets sucked into a what's called a mass spectrometer. So it's basically an instrument that measures the mass of different atoms. So you're measuring the mass of different atoms. Yeah, from inside a little mineral crystal, and the crystals are like, if you pick them off like smaller than bits of sand. If you sneeze, you lose the whole thing. Anyway, so there's this great whole science around how you do that. Yeah, we're lucky. And so you can measure things at all kinds of scales as well. So I was sort of thinking towards scales, which is it's like nanograms of a single mineral, like in a sliver of a rock that you carried in your backpack. But what you can do is begin to talk about the history of, the assembly of continents, ancient continents. You can start to talk about the history of mountain ranges just from your nanograms inside a mass spec measuring the weight of atoms. You can begin to reconstruct ancient Earth. That is a ridiculous variance in your scale. The scale of understanding. Process. Yeah, geology is actually quite incredible like that. Yeah, you do get to go from the nanogram to the kilogram to the how many bazillion grams in a continent. Absolutely. Yeah, and looking at the different types of geological phenomena. So those sandstones you were looking at up in Kakadu. So what's your sort of feeling for, like, what formed them? Is that something which took a long time, or? Okay. I got big water energy from these rocks. I was looking at them going, this had to be sculpted by water. You had like, it was sort of it was like a bit of a conglomerate, which is rocks in rocks. And sort of what I deciphered is everyone was waiting for me further down the path, and I was taking. I was like, where the hell is Holly?
yeah. She's hugging the rocks
again.
You can sort of begin to understand that. I think that this was probably once a big river system, super high energy. It had pebbles strewn through it. You could see little layers where perhaps it was a little calmer, and you weren't sort of depositing tumbling pebbles, but it was just sort of a little calmer, and just a bit more siltier stuff was falling out of the water column. So definitely by the action of water. So even though, water exists in our present moment, you can go into a creek or into a river and you can be really still and just be sort of really aware of the current and the torrent that's coming through right now. But that over the course of not tens of years, not hundreds of years, but thousands of years and millions of years, that begins to build quite a thick record of what that river once was. And that sort of duality of time is a remarkable feature of geology. But we often talk about this, which is humankind tends to exist, you and me, we exist in the right now. I exist in the I missed my bus by a minute, or I burnt the toast. I should have gotten to it 30 seconds ago. We tend to exist in the right now, and the right now is fleeting. And the beauty of geology is it lets you escape that. I went and saw Neil deGrasse Tyson last week, and I don't want to misquote him, but he sort of called us prisoners of the present. And I guess you can consider yourself a prisoner, or you can say in this present moment I can understand everything else. But I know that you feel a similar way about that duality of knowing the present for what it is and looking at rivers flowing, and the Himalayas look pretty static. But by looking at the rocks, by using these zircons, by dating them and using the power of geology, you can actually escape those prison bars and look into an immense geologic past.
Yeah, and absolutely. And that's why you faint when you go to these old rocks. Well,
Yeah. You're projecting there. Yeah.
Some people faint when they go to old rocks.
Yeah.
But yeah, I mean, you can't help. And like you say there, so you were looking at this ancient riverbed, and you could picture the calm times, and the storm went through, and a flood, and lots of boulders, some bigger boulders, some smaller pebbles, whatever, were tumbled down that river, and you're looking at the layer upon layer,
for sure,
up in those sandstones.
And it's sort of when you're at eye height, and of course you stay behind bars, you respect. Sort of, if you're near rock art, don't you dare go near those rocks.
Art, of course.
Yeah, we're not talking about the rock art. This is sort of more the random boulder. And you're sort of at eye height, and you sort of look down, sort of diagonally down near your nose, and you can see finely bedded, like silty grains where it was sort of low energy. And then you sort of you peer upwards, and you start hitting those coarser pebbles. Like, what's a pebble doing in a rock? What's a rock doing in a rock?
Shouldn't be there.
Shouldn't be there. How did you get there? And as you're gazing your eyes from honestly only over the course of about 30 centimeters, you're traveling through time. And I'm not saying that to be like some waffling science nerd. You really are able to time travel if you just sort of start thinking and asking why and how.
That's true. It's time travel, isn't it? Yeah. You can't necessarily physically travel in time, but you can definitely.
No, you're watching how that river evolved over a time which you'll never experience as a human.
That's right. But you can see the imprint of it, the record of those things, and that's one of the great things about. I mean, that's what makes history so interesting to people. When they could see, this fort was occupied by William the Conqueror or something like that, and they can look back and they see that history, and people really connect to things like that, or the Great Wall of China, and you think, oh wow, this was built in this time, and so we as geologists, we see that for all the other processes that go on in the natural world. So. Like I was thinking of things like volcanic rocks where, you can see something which has happened more or less instantaneously and quite violently, as opposed to your, bubbling little brooks that you're talking about with those sediments. Although I've got to say those billion-year-old or whatever they are, rocks up there are probably not bubbling little brooks. No. They're probably big torrents, but they were, but an instantaneous kind of explosive eruption, like the classic ones, like Mount St. Helens in the western US. We've seen lots of things happening in Iceland in the last few years, where you got
beautiful footage coming out of Iceland.
Yeah, these volcanoes which are erupting now, and it's just sort of more like in a geological timescale that's instantaneous. And we can go back in time, and I've certainly been to places where you can see volcanic rocks from 1.6 billion years ago. And what's amazing about these ones is that they're basically they look like volcanic rocks that are erupting right now.
Yeah, it's the same shit, different day. Billion years later.
Yeah, it's amazing stuff. Yeah, the duality of time. Yeah. You have these sort of, so there's in one way that time is continuous, right? And we can look back at the Earth's history and we can say, there's this continuum of process operating all this that time, but that continuum is punctuated by big events, and those events can be rapid. And they can be, like thousands of years, or they could be tens of years. Like a big flood can be almost instantaneous, but you might deposit a huge, out in a river delta, you might deposit a huge amount of material just from one massive flood event. So, yeah.
That sort of rings some bells. One of my first, very small scale little research projects I was part of in second year at Uni Adelaide was just doing the zircon prep work for dating a meteorite impact that exists in outback South Australia. It's called Ackerman Meteorite Impact. And oh goodness, my facts are going to be a bit sketchy, but it exists around the time of first animal life. And because a meteorite is fast, like we're not talking about the river which took 1,000 years to deposit its pebbles. This is a meteorite impact is bang, done, right? And so it's a real snap moment in time. And so if you can hang if you can hang history on snap moments of time, it's a pretty powerful thing. It's a very different outlook to trying to decipher a million years in 10 centimeters of rock. That's 10 centimeters of rock that happened right then and there in that moment as that meteorite smashed Earth. Those
meteorite impacts were very, very prominent early in the solar system. There was so many like lots of accretion in the early accretionary phases, and you can see that on the moon. The moon still preserves a lot of that early record of the meteorite impacts that the Earth would have also experienced, but because of surface processes, because of plate tectonics, we recycled a lot of that. We don't see them, but they do happen occasionally. So there's another classic meteorite impact. Thinking of that is the one that happened, which helped to end the long reign of the dinosaurs.
Oh,
poor dinosaurs.
Yeah.
And so that and you can see. So in that, what were you actually sampling? What material were you?
It was the ejecta layer. So when the meteorite smashed into, it must have been. It was Air Peninsula.
Yeah.
It flung up so much like pulverized dust and rock, and it really smashed up the ground, and that sort of cloud of material wafted over to the Flinders Ranges, which was under a shallow sea at the time, and all of that sort of ashy pulverized rock then settled down to the seafloor and formed a couple, like it's...
How thick is the layer?
It's about 1 centimetre, and it sort of pinches out
it's
in places.
Tiny. It's like a
it's
little
very
ribbon.
Tiny. Yeah, but
which you could easily walk over if you were just traversing it. You might not really realise the significance of that one tiny little layer that marks a particularly explosive period of 100%. Event.
And then even above that layer, there's evidence for the tsunami that followed. It's encoded in the rocks. And so, there you go. We were talking about this sort of Kakadu sandstone, which took millions of years to deposit. This is a meteorite impact that had like bang, ejecta layer, bang, tsunami, like all in one moment.
Yeah, we've lived through tsunamis, or not personally, but we've seen them happen in the sense that how rapid they are.
Yeah.
That's what I meant by that.
Yeah.
Anyway.
Yeah. And that's creating geology into the present,
creating
right?
geology. And it leaves a record, and that's what geologists' job is, to go back and read that the book of time that's written in the rocks. That's what it is.
Mm-hmm.
It's amazing stuff.
For sure. And I think that point about the like earth science and earth history continues to the present day. I think I made a comment in an earlier episode, which was I get frustrated when you hear people talk about humanity as sort of the end of like earth history.
Yeah.
Because you think, no, humans are still of earth. Like we are made of earth material. We exist in a complicated natural system. And, it's sometimes easy to fall into a pessimistic way of thinking, which is like we exist in quite the disequilibrium of geologic timescale. We are a very, very fast force, and sometimes it's going to cause us grief eventually.
Sadly. I guess we're reaching up against the limits of what our environment can sustain, right?
Hugely.
Yeah. So we will leave a record in the in the geology of the Earth.
Well, yeah, in the geologic timescale, there's the scientific debate at the moment is, do we live in a sort of definable human moment in the geologic timescale? The Anthropocene. Yeah, that's not a good one, guys.
Well, I mean, it's an amazing one as well. I mean, I remember my cousins saying to me, yeah, but humans are natural too, and it's true. We are natural. We just worked out how to...
The unnatural forces. Yeah.
Well, yeah, we are. Yeah, in some way it is unnatural.
But at least that same, in the same way that we use the natural world for our energy, in the same way that we use the natural world to build our homes and cities, like we also understand it. And so for a lot of people that maybe live in suburban centres or dense population centres, heading out into nature can be a very profound, experience to feel bigger than yourself. And it's through this lens of time. It's by understanding that when you traverse the landscape, or even just simply look at the cliff you're sitting on, or look at the coastline that you're sort of a part of, you're experiencing an antiquity of nature. Right then and there. There is a common geological heritage that extends way past your fleeting moment. And that's yours to connect to it anytime you want to. And that's the story of the geologist. That's where the emotion is, isn't it?
Absolutely. Let's get out there and experience it.
For sure.